Yes.
Good. So Kunal, what are we going to be learning about today?
So today we'll be learning about stateful and stateless. I'm really excited to share my knowledge, what I have learned about that. I'm a beginner in that particular topic, and I got to know about that in from the DoK community only. So yeah, I'll be sharing my knowledge and hope everyone understands that.
Okay, cool. So if you want, you can share your screen. Go for it.
Yeah, sure. I hope my screen is visible.
Yep, looks great.
All right. So, hello and welcome everyone to the DoK Students Day. This event is like a pre-KubeCon celebration, and most importantly, it is by the students and for the students. So, most of the talks today would be given by the students, and you'll definitely be seeing some very new faces here. So, let's jump into it. Yeah, my name is Kunal Verma, and currently I'm pursuing my bachelor's in IT from India. I'm a sophomore, so currently a student. I'm an open source enthusiast, and I really love to interact with people in the community. Currently I'm an intern at the DoK with an amazing team, Vanshika, Kavalya, and Karuna. And yeah, I am currently learning and contributing to the Kubernetes project as well. All right. So the topic for today is stateful and stateless. So this is a really important topic if we talk about in the cloud sense, and we have talked about this in the DoK community, whether that's in the meetup or having a general discussion in the Slack. By the way, if you haven't joined our Slack, what are you waiting for? Just do it right now. So we'll be discussing some of the main crux about these topics and what does these two terms exactly mean. Let's jump right into it. All right. Let's get a basic overview of what is stateful and stateless with very simple real life examples, so you'll understand much better about that. Starting with the stateful. All right, so consider a situation where we have Bob right here, who just got his salary. You can see the happy smiley face, and he wants to transfer some of his amount, say $1,000 to John, right? Now he heads over to the bank's website, that is mybank.com, and to the login page. So he says to the website, "Hi, I'm Bob, and I can prove it by entering my password and login here." So he does that, and then he moves on to the step two. He says, "All right, hey, remember me? I just entered my password and login in the previous step. Now I want to make a transfer request to my friend John right here." After that, he heads over to the step three, and he says, "Yes, I have confirmed all the previous details, and now I want to confirm my transfer." Now, what do we observe from him? We observe that in order to complete the steps ahead, the completion of the previous steps was necessary. And most importantly, the site remembers that the previous steps was completed. So now, in this case, in order for the site to move ahead with step two and three, it is important that the step one is completed and the site remembers that it was completed. Now, how does this happen? This is what is called is persistent storage of data, on which we'll be shortly having a talk by Vanshika. But basically, what that means is even if the session or the state in this case can be defined as an activity that is being happened at the particular time. For example, entering the login and the password was a particular session on the state. So even if the particular session of the state was completed and we moved on ahead, the site remembered, that the data was not lost from the previous session and it was used to make further requests. This is actually what is called persistent storage. And this whole process, this is what exactly happens in stateful. There's a persistent storage. So even if the session data or the state data is lost, we can retrieve it from that persistent storage, and we can use it to make further requests ahead. So I hope this was easy to understand, and this example helped you to understand the concept. Now, moving ahead with statefulness, and this would be really easy to understand. So, consider a situation like we all use search engine each day, right? Do comment in the chat which one is your favorite. My favorite is Google Chrome, obviously. So, we all use search engine, and let's consider an example where you are searching for a particular question. So, in this case, like how to write code. I'm a beginner and I want to search how to write code. So what normally happens is we search on Google, and then we like the results are displayed normally, and we can find our answer most probably. But then you by mistake refresh your browser, and or your tab gets closed. Boom, everything you searched previously has now been vanished. So how did this happen? This is what exactly happens in statelessness. So there is no persistent storage. That means the, if the data once the data is lost, your data will not be stored in particular storage area. So you have to start every time, you have to start from scratch. So then you have to search again of the topic that you are going to search. So this is exactly what happens in stateless. So there is no state, that is no state is maintained. So I hope that was clear to you all. All right, so now looking into the world of clouds, we have some use cases here. Like the databases we have, you may have heard about MongoDB, MySQL, and Cassandra. They all are based on a stateful architecture. That means they have some kind of a persistent storage. So it's easy for the data interaction between the user and the databases. So we can easily retrieve our data. And now talking about the present times, what is happening is previously the many applications were written statefully, so they were likely to rely heavily on state data. But now as we saw stateless, so obviously stateless has simpler architecture as compared to stateful. So now if we think of the situation, refactoring all those stateful applications to stateless was a little bit of tedious task, because there was time constraints, and that would cause a lot of expense as well. So what is now happening is the tools, the famous tools that we know, that Kubernetes and Docker, they were originally written in stateless, but now they are developed. They are being developed to write more. They are being managed. They are being written in more for managing both stateful and stateless. So now, for example, if you talk about Kubernetes, it is most actively being used to run databases. For example, we have Cassandra, which is Cassandra, that is a stateful database which is running on Kubernetes. So we have a really good example for that. And so the DoK community was formed. So like concentrating on more of the aspect of running stateful workloads or applications on Kubernetes, and like spreading awareness about basically running data on Kubernetes and the best practice related to that. So you can definitely see we have a really nice live example in front of us today. All right, so I hope this was a really nice overview and you got an idea about what is stateful and stateless. Now quickly going back to the things, stateful, it uses some previous state or session data to make new requests and further requests ahead. We have in stateful we have a persistent storage to store the data, and that can be used to make further requests ahead. Stateful has a little complex architecture, because it has a persistent storage, obviously, and the interaction between that makes it a little bit more complex. Moving on to stateless, previous session or state data is not stored anywhere. It gets lost. So every time we start, we have to start from scratch. Doesn't have a persistent storage, so the data is not saved anywhere, and it has some kind of a simple architecture, as there is less interaction between the data, and we don't rely on the previous request to make further requests ahead. All right, so I hope that you got a clear idea, and now I have a task for you all. So these are some of the resources that I would recommend anyone who want to dig deep into that particular concept. And let me tell you, this is a really important concept, and I would highly recommend everyone to check out these resources. These are the ones that that I use to create this PPT and the talk as a whole, because I am a student and I was a beginner in this topic. So I hope these resources help you a lot along your way. So thank you everyone for listening to me today. I hope that I was able to provide sufficient information to anyone who want to explore more about this topic, because that was a short talk, and I couldn't explain everything in this particular time zone, but I hope that it helped you all in getting a basic overview about this. Feel free to ask any questions you have. You can always ping me on Twitter, LinkedIn, and GitHub, and we can have a conversation there as well. So yeah, that's pretty much about me. Thank you.
Awesome. Very, very good. Maybe I'm muted. No, I'm not muted. Good. Kunal, thank you very, very much. As Kunal was mentioning as well too in the panel, we got to know each other for the first time actually in the previous KubeCon in a mentoring session. And here we have Kunal now providing some mentoring to other folks. And I can't say it enough. He's one of the most welcoming people we have in our community. Anytime new folks are coming in, very patiently guiding them. Actually, a bunch of people have just been joining us on Slack. So Kunal, you're probably gonna have some work to do. But anyway, very, very nice overview of a concept that's extremely important to our community. As he mentioned, Kubernetes was originally designed to only run stateful workloads, stateless workloads, applications, etc. And now in our community, what we're trying to show are the practitioners who are running stateful workloads, whether it's through storage, databases, all the different elements where we see that with analytics, different areas in the Kubernetes ecosystem where stateful workloads can be run. So it's a very, very nice overview to get a clear picture about what it is that we're trying to deal with here. Kunal, thank you very much for your presentation. We're going to jump right into the next one.
Yeah, thank you so much.
Cheers.